marketing purposes. This session will contain 3 parts. First, I will tell you all about lessons learned from the policy point of view. After that, our UIA expert, Elma Durmisevic, will tell you briefly from her expertise point of view what the project taught us. And at last, there's some time left to ask us questions to ask questions to the both of us. Before I start telling you the lessons we've learned, I briefly tell you a bit about the regional situations to explain to you why this UIA project is such an important example project for our region. Let me start with telling you all where we are situated right now. We are situated in the Meuse-Rhine region with almost 4 million inhabitants. The region Parkstad consists of more than 250,000 inhabitants, and that's exactly where the red pointer is pointing to. Parkstad-Limburg is an administrative collaboration of 7 municipalities in the southern province of Limburg, one of the 8 metropolitan regions of the Netherlands. The coal mining industry started industrialization in the late 19th century. This resulted in urbanization and agglomeration during that time. As you can see on the slides, you can see that the density of the buildings is rising, and therefore, in the end of 2015, we have an urban area in this area. Parkstad was therefore a prosperous region, and the large cities in the Parkstad were high on the list of the most wealthy municipalities in the Netherlands. As you can see here, the 4 big cities in Parkstad were in the top 20 of wealthiest cities in the whole of the Netherlands. But after that, the mine closed. So around 1965, the mine started to close, and therefore Parkstad got its first big transformation task. We had to transform from black to green, meaning leaving the mining industries and start to build a new economy. The closure of the mine resulted in the loss of approximately 17,000 jobs. You can imagine on a number of inhabitants of 250,000 that is really a big amount. Therefore, we needed to create new jobs and needed help from the national government. We are now facing a new transformation in the region. We have a decrease in population and therefore a major transformation task. And that's physically, economically, and socially. Restructuring became a central theme next to socio-economic development. If you take that 2 numbers, it means that in the next 10 years, we need to demolish 7,500 houses. We get to get rid of 130,000 square meters of retail and 20,000 square meters of offices. And we also have to build 1,500 new houses that meet the nowadays standards and needs. So you can conclude that our task is, it's a big task for the whole region. With such a big restructuring and transformation task, you cannot ignore the circularity discussion. Circular building is a theme that combines the central themes within Parkstad, the restructuring and the socio-economic development. Therefore, Super Circular Estate is a really good example project for our region because it's an integrated and innovative area development. But not only from the reuse of materials, but also for the reuse of social values. So also its citizen is an important part of this restructuring. Within the region, we have a region deal Parkstad with a lot of new area developments. And therefore, it's very important for us that we use the lessons learned from this project and use them in the next and future project. And then, of course, what did we learn about the Super Circular Estate project? I will tell you, we learned really a lot, actually. But we will tell you briefly a few important ones of them. It is important to make sure that you have a clear goal and ambition at the start of a project. such as super circular state. It is very important that all partners aim for this common goal, because you are experimenting in a project, and therefore the path to that goal is not yet defined. Not everything you initially came up with will work. Often what is on the blueprints is not what it is in practice. Within an innovative project, you sometimes have to take one step back to get 2 steps ahead, or to get 2 steps forward, actually. Do not see errors in the process as a failure, but try to learn from it. So within the partnership, you have to be flexible and collaborate in order to learn from your mistakes and to achieve that agreed common goal that you set in the beginning of the project. So once more, when you start such a project, it's important to decide at the start what goals you have, so that you know what you aim for with all the partners involved. Second important lesson to learn is that if you want to reach the mentioned goals, it's very important that your partnership is a strong one. Within the project, we collaborated with parties within the whole triple helix. That means we work together with government, with the housing corporations, but also with industry partners and the knowledge institutions. The partnership is therefore very important to tackle all those complex issues you face in such an experimenting project. And furthermore, you can ensure that supply and demand are aligned. So you have to make sure within your partnership that there is the right demand for the available supply. Innovation requires a learning character within your process. Through close cooperation, you can quickly anticipate on changes and barriers. It is important to start discuss your plans with the various stakeholders early in the process, so that you can coordinate all interests and ambitions from start. After that, it's really important that you take into account the design of a new building. Because if you want to avoid running into the same problems again within the upcoming 30 years, and so the moment when you want to renovate or demolish some new houses or the building stock, you have to make sure that your design is circular, and it is important that you develop building concepts that are detachable and in which materials can be recovered in their high quality, and that you can use them again in a second life cycle. So by designing in a circular way, you can ensure that the materials you use for the construction can be used in multiple life cycles and remain the value of those projects. And there is also, of course, from my policy point of view, the restrictions in law and regulations. As an example, we faced an issue with the Building Degree Act, in Dutch called het bouwbesluit. Within the law and regulations, we ran into certain problems when we wanted to reuse materials. In this specific case in super circular estate, we wanted to try. We could not comply with the Building Degree Act, because we wanted to build a ground floor at the correct height. As we lifted the hole directly from the flat, as mentioned in the previous sessions about this project, we had the problem that the permit was not granting access. The access because the ceiling height could not change anymore, and therefore such problems should be solved. And also the actual building, which was the start of this project, has been granted a permit that is as a structure, as a work of art, because otherwise there was not possible to get a permit for such a building. It's therefore very important to make these matters negotiable, and legislation and regulations should be changed according to this new developments. In addition, it's also important that as a government, we ensure that we produce and develop flanking policy, ensure that circularity is applied in the various domains. An important role for the government that we can play is that of a launching customer. Through circular tendering and circular procurement, it is important to do this so that the market is also stimulated to innovate and create business. In order to organize the circular economy, we must ensure that supply and demand are aligned. Our last big lesson learned is that we should share, and share. It is very important that we ensure that we share all the knowledge and expertise that we gain in these types of projects. This project is, of course, an open source, so all our expertise is open for every person and everyone who is interested. But sharing is so important because all kinds of things are happening on these topics in so many places that we cannot figure out what's happening everywhere. And therefore, we have to prevent that everyone is reinventing the wheel again. So it's very important that we tell what we learned and tell everyone our expertise and what we did wrong, but what we also did good. Next slide. For now, it's really important for us that we are trying to realize an upscaling in the upcoming restructuring projects in the region. But we also are experimenting with more new circular projects. I named a few of them: Drive Zero, Digital Deconstruction, Reuse Material, GTB Lab, and the Resource House. Because of our big transformations, we want to get back to the roots of the area and be an urban mind for the construction sector. Now we will continue with what Elma Durmisevic has to say about the lessons learned from this great project. Elma is involved as a UIA expert in the project, and Elma will now take you along in the lessons learned from the perspective of the expert in the technical field of the circular construction. Elma, the floor is yours.
Thank you, Paul. Thank you very much for the introduction, and I'll quickly share my slides. Can you see my slide?
Yeah, you just have to enlarge it now.
Big enough?
Yeah, perfect.
Okay, so I will tell you something more about technical aspects of a super circular estate project and of obviously lessons learned. As Paul mentioned, there are quite many lessons learned, in particular because this is a really very unique project in Europe. It is looking at and it is trying to understand the capacity of existing buildings and building stock to function as bank of materials for new construction. And as Paul mentioned, the region of Parkstad and south of Limburg is facing a kind of very ambitious transformation phase in terms of urban transformation. A number and thousands of houses will need to be deconstructed and replaced by new ones, where the question would be, is there a capacity in the existing buildings in the Parkstad to set the new standards for circular building and use this opportunity for transformation and urban transformation, which is on the agenda, also as an opportunity to make a swift transfer towards a circular economy in construction. So that's why this project really plays a very important role in that understanding of possibilities and what can be done also from policy point of view, but also from industry point of view, as construction companies are very much interested in making changes in methods of construction as well. So the project aimed to literally reuse existing building block and its materials by deconstructing parts and reusing its elements and materials in construction of 3 new circular houses. And in this process, the consortium of 12 partners basically had to reinvent protocols for each particular phase of the development of such circular building. Starting from inventory, how do you analyze your building and its stability, the usability of its materials? How do you develop your material passports? Those are all steps that the consortium have done and was facing during the project itself. Coming together and also trying to understand the shifting of roles of stakeholders in construction during the design and construction process, where the deconstruction company was not at the end of the life cycle of a building, but plays important role in decision making in the initial design stage of a project, for example. All these things had to be sorted out, and some kind of protocols needed to be developed in order to move the project further, and also to come to the decision on which parts of the building will be reused, what will be a material pool for the construction of new houses, and how the new buildings will look like. This is the result. I'm sure you have seen these pictures already. There's the 3 houses which have been built using the materials from neighboring 10-story building. And the consortium achieved the ambition, I could say, in constructing new houses while reusing 90% of materials from existing building. Basically, almost 100 tons of material has been built, reused material has been put into these structures, which is just 90% of what you would need to construct them anyway. And some 70% of CO2 has been saved by these actions, which is quite a big achievement of such a huge experiment. So the consortium tried to understand and test a number of deconstruction and reuse strategies. And obviously, building is a complex structure, and it can be dismantled in different layers. It can be decomposed on different levels. And we can also talk about deconstruction on the building level of bigger chunks of materials, deconstruction and reuse of systems, components, elements, and I can go back to the material level as well. So the project itself tried to address all these levels of building composition and its decomposition, and do the monitoring of the environmental and economic impact of these actions. So as you have seen on the highest level of reuse, direct reuse, the big units have been reused. Of course, lots of that required lots of engineering around the stability of the building itself and elements which remain after taking and cutting unit out, to how you host the units from 12th, 10th story to the ground and so forth. The other level that was investigated was reuse by direct reuse or remanufacturing of components and elements of the building by creating new facades or windows, reusing doors. And the last level in the hierarchy of materials in a building is the material level, where the recycling of the existing concrete has been tested, and a new methodology and technology has been developed to create a new concrete while reusing 95% of aggregate from existing concrete, which has been quite a big achievement. So through all these exercises, one of the driving forces was to try to understand how to revert what we call in the linear building construction, this linear material flow through all phases of a building life cycle, which starts from extraction of raw material, production of elements, assembling in a building, using the building, then demolishing it, and basically throwing the material out and bringing it to the waste disposal sites. This is a linear way how we dealt with buildings up to now. And this project tried to understand how this linearity can be reversed into circles, into circular recovery loops. And obviously, when we talk about closing the cycles in the building and the reuse cycles, we realize that there are different sizes of these cycles. And the shorter the reuse cycle of an element, the better impacts will be on the environment and economy. So this, what you see here, is one of the exercises done on the recycling of material. That implies that the cycle of retrieving material is quite large, and that means that there are many processes involved in deconstructing the existing building, creating aggregate out of that, and then processing it again into new material. And obviously that requires more energy, and it's more costly. All these steps and the different deconstruction concepts have been monitored by Zuid University, and they also produced quite interesting reports on the environmental and economic impacts of these steps. I'm sure these have been discussed during the conference, but what is interesting to see is that, for example, even on this level of material reuse, some environmental gains can be seen, although they are not reflected in the price of construction, as the researchers at Zuid University took into account the existing CO2 tax, and when calculating those external costs of construction with environmental impact, these external costs are almost the same like external costs of conventional construction. But that can be improved by changing the taxation policy. On the other hand, we also see on the internal costs of the actual construction costs, quite a big discrepancy in costs of the recycled concrete and the costs related to the conventional construction of concrete floors or structures. And that has to do primarily with the process, quite heavy process involved in recovering aggregate, and the price is like 3 times higher than conventional construction. However, during the Super Circular Estate project, improvements have been done on the technology of producing and creating this structure, the recycled concrete. And in a spin-off project, which is finalized, or it's being finalized one of these days, another 15 apartments, this cost has been reduced to only 20% above the conventional construction cost. So significant improvements have been already achieved on this level. When looking at the other cycle, closer, smaller cycles of reuse, like direct reuse of the units, 3D units. Interesting, this is quite important conclusion actually, because basically, as I said in the beginning, the shorter reuse cycle of element is from the building, the better results will be for the economic and environmental impact. Here we see an attempt to recover an element from the building which was never designed to recover elements from the building. It is a static structure which needs lots of equipment and effort in order to take something out, and many safety measures also need to be taken into account. So when looking at the impacts of recovering direct reuse of such huge elements from buildings which were not designed for recovery and reuse, we also see in the economic cost impacts that the financial feasibility of such operation is not there. So basically, this kind of operation is almost like 10 times more expensive than building a new structure in concrete. However, on environmental impact, we see that there are obviously a good and positive results of reusing this chunk from existing building, primarily in a saving of raw materials. The same counts for...
Sorry, we have 3 minutes left, so
that will
make it quick so that we can answer the question of Marjan as well.
Sure. So to summarize this part of the story, the thing is that when in the end the cost calculations have been made for the construction of houses, of 3 circular estate houses, the square meter price is like 2.5 times higher than the conventional square meter price of the similar house built with the similar materials. And brings us to one of the important conclusions is that, and also recommendations for the future policy developments that will support circular construction, is that although we see that buildings are built and with very good environmental and low environmental impacts, these buildings have reused 90% of materials, 70% of embodied energy, lots of CO2. So on that side, we are okay. But when we look into real economy and economic impacts, we see that such a building is 2.5 times more expensive than a conventional one. That comes primarily from this fact that we deal with buildings which were never designed to be recovered, dismantled, and their materials reused. And therefore, the recovery operations are very complex. And in this case, for hosting this huge 3D unit, 7 companies were involved, and you can imagine how much coordination work need to be put in place. So that kind of operations obviously are not feasible, and that's quite an important lesson learned for the future. So when we look into the difference between a linear or conventional projects and the construction projects and the circular, obviously in the conventional projects, when we talk about deconstruction, we talk only about the cost. So the deconstruction and demolition of conventional buildings involves only costs. There are no benefits. Now we are trying to go and move to another world, the circular world, where the costs on one side of deconstruction can be mapped with some benefits. And that's where we are now as scientists and policymakers in understanding how to optimize these benefits and level the benefits with the costs in order to make the sustainable circular construction projects feasible in the near future. And as I mentioned, one of the quite straightforward lessons from the project are illustrating that for the future buildings that need to be built, the high reversibility of the structure is definitely something that need to be a must, as we know that high reversibility index results in the low deconstruction costs and low environmental costs, and other way around is also true. So my last slide here would be about the main findings and recommendations, and I'll try to go through that quite rather fast. There's
yes.
Conventional supply chain hierarchy is not applicable in circular projects. As I mentioned at the beginning, there's the role of the construction companies, for example, is changing, and the construction company becomes a supplier and therefore regains another position in the design and construction process. And that is true for other stakeholders as well. Existing building stock, as already mentioned, was not designed to be deconstructed. And that is why recovery of materials is very labor intensive. Materials are damaged during the recovery process and they lose value. And high labor costs, therefore, in the construction projects cannot compare with low price of virgin materials. So that's why we don't see many circular building projects popping up, because they cannot compete on the market with the existing taxation policy. Circular estate savings in the raw materials, as I mentioned, CO2 emissions and energy, are very high, but they are not reflected in the construction costs and market price at the moment. There's the lack of circular building legislation at the moment. Due to this lack, there is a disbalance between the cost of linear and circular building on the market, and without regulation of taxation policy, standardization of circular building quality, what we see as a standard, circular building projects will not be competitive on the market in near future. The recommendations are also linked to a couple of additional things. This internalize external costs as CO2, embodied energy, waste disposal tax, and so forth as building costs, standardize circular building quality, and introduce a quota for the application of reused materials and recycled materials in new construction and construction products, prescribe reversibility index in new building standards. Possible options for new taxation policies would be reduce labor tax, increase taxation on raw material, increase tax on CDV, this construction demolition waste, and introduce disposal fees for projects with low reversibility index or score. The main takeaways basically are the two, you heard quite often about them. The biggest impact can be reached by designing of new buildings with high reversibility rate. And one of the examples and tests have been done during Super Circular Estate project, where the bricks you see here on the right-hand side have been developed as reversible components and parts which can be used to build new buildings and then reuse in another one as well. And the standardization and industrial scale of production will reduce costs significantly. And for that, there's also a nice example of a field factory that has been further developed for recycling of concrete, and huge savings have already been achieved in the construction of buildings with reused concrete. Thank you.
Yeah, thank you, Elma. A lot of lessons learned indeed. Another conclusion we can make is that we learned so much that then half an hour is not enough to share all lessons learned. So Marjan, I will write you a brief answer in the chat. Indeed, I think we should quickly go to the plenary part, because there will be a recap of today, and there are some interesting facts. I think they will tell us again. So thank you everyone for your attention. Elma, thank you as well for your contribution to this sub-session. And Marjan, I will write the answer after I closed this meeting. Thank you very much, everyone. Bye-bye.
Thank you. Bye.